Hello students, welcome back to chemistry class brought to you by ighota virtual learning platform. I am Olabisi Olawoye and I am your chemistry tutor. Today we will be considering a very important topic, which is the last part of the kinetic theory of matter, and that is the natural phenomenon supporting the kinetic theory. And the two parts we are considering, though, the two phenomenon are Brownian motion and diffusion. And at the end of this class, questions have been carefully selected from past questions to back up this topic. And don't forget that most of this, in fact, all the topics we treat here are carefully selected from the Waec syllabus. And so I will advise you to follow this series. And if you are yet to subscribe to this channel and share to your friends as well, so that they can also benefit from this class. So the first part here is a Brownian motion. Now, the kinetic theory of matter actually believes or assumes that matters are made up of very tiny particles, ions, or molecules, and that these molecules or ions are in constant motion. And we also considered in the last class, the structures of solids, liquid, and gases, and their particles and their behaviors. And there are some phenomenon or natural occurrence around us that supports that the particles of solids or the particles of liquids or the particles of gases are always moving continually, colliding with themselves and with the wall of their container. And so one of these natural phenomena that supports the kinetic theory of matter is the Brownian motion. What is a Brownian motion? It's actually an irregular movement, like a zigzag manner of a suspended solid particle in a liquid or air medium. Now, it supports the kinetic theory that all particles are in constant motion. I'm going to be using a very good example, using an experiment whereby particles of turmeric powder or sulfur powder dissolved in water moves about until they are evenly distributed in the container. It started from a region of higher concentration where the powder was introduced, and it moves, and it is supplied to all the parts of the water in the container, and this shows that the particles are always moving. Another experiment to support Brownian motion is whenever we sweep dust particles around us, and these dust particles, maybe we sweep or we dust our furnitures, we see dust particles being suspended. These dust particles are in form of solid, and they are being suspended in the air. And when we look at the air far away from us, maybe where there's a reflection of light, we will notice that these dust particles are actually in the atmosphere, and there is a kind of movement that they undergo. There is always a constant movement. They're always moving. And when we take a close look at them, we see that there are tiny particles suspended in the air, and they are moving continually. This is also Brownian motion, and their movement is not regular. It's zigzag manner to show that particles of solids, liquids, and gases are always moving continually. You can see here that the solid particle is dispersed in the air medium, and there's a form of movement. There's a movement, a zigzag movement, and this shows that kinetic theory of matter is true, though it can be adjusted, because that's why we call it theory. Theory can be adjusted to form law, and the regular or real gases does not obey the postulate of the kinetic theory, but the Brownian motion is actually a natural occurrence that supports the kinetic theory of matter. This is the irregular movement we can see the particles moving about in a zigzag manner in the air, and that supports the Brownian motion. We can see here that if we had a few like a spoon of turmeric powder to water, the powder of the solid, that is the solid particles, will move in the water from a region of higher concentration to a region of lower concentration. And from this experiment, you could see that the particles of turmeric keeps on moving continually until it gets to the bottom of the container, and until the particles are evenly distributed, and the particles still continues to move. So this is to support the theory that matters are made up of very tiny particles that are moving continually, colliding with themselves and with the wall of their container. The next experiment or phenomenon that supports the kinetic theory of matter is diffusion. It is actually a movement of solute particles through a medium. It can be the medium can be a liquid, and the substance to be diffused can also be liquid or gases. The substance to be diffused can be liquid in another liquid medium. Now, diffusion is actually a phenomenon whereby solute particles, that's like a solid, moves from a region of higher concentration to a region of lower concentration. And there is an experiment to back up this phenomenon, whereby a sample of food color is added to a liquid in a container. Now, from where the food color is, there is a movement from that place, which is of higher concentration, to a region where there is no food color, that is lower concentration, until the solute particles of the food color are evenly distributed. This shows that solid particles or liquid particles in another liquid particles are always moving. They are always moving continually, moving from one part, especially from a higher concentration to a lower concentration. Osmosis is another phenomenon, which is a special form of diffusion, whereby there is this movement of solute particles from a region of higher concentration to a region of lower concentration through a semi-permeable membrane. That is, there will be a medium through which these solute particles move. This all supports the fact that matters are made up of tiny particles, and that these particles are always moving. Whether they are in solid form or liquid form or gaseous form, they are always moving. They are moving. Whether they are in liquid, they are, even when they are added to liquid. Now, let's look at a very good experiment here too. Now, we can also see in this diagram or illustration that there is a drop of bromine. Bromine is actually an element in liquid form. In a container, there's a drop of bromine. And after some time, you can say that the vapor of bromine has filled the whole container. This shows that the particles of bromine, which is in liquid form, are always moving continually. And this is to support the kinetic theory of matter. So now we are moving over to the revision of treating of past questions to back up this topic. I will advise you to participate by attempting the questions first before watching the solution. So I will also pause the video here, then we'll come back and solve the questions together. Addition of a fruit color to water shows the way liquids. It is in liquid form. Can you see the way it travels down the water? This is diffusion from a region of higher concentration of the food color to different areas of the water, where there is no color until it is evenly distributed. This indicates diffusion in liquid, that water molecules or molecules of the food color also travels round until the concentration, which is the color, is evenly distributed round the water. That indicates diffusion, which supports the kinetic theory that molecules or particles of solid, liquid, and gases are continually moving. They are always in constant motion. Hello, welcome back to past questions revision class on Brownian motion and diffusion. The first question here: the spreading of the scent of a flower in a garden is an example of what? A. Brownian motion. B. Diffusion. C. Osmosis. D. Tyndall effect. Brownian motion is actually a zigzag movement of particles of solid in liquid, while diffusion is a movement of solid particles, from a region of higher concentration to a region of lower concentration. Osmosis is actually from a special form of diffusion that requires a semi-permeable membrane, while Tyndall effect is just the scattering of light by the scattering of rays of light by a colloidal solution. So the best answer here is diffusion. Diffusion, because the scent of the flower is made up of particles that are moving continually in gas. They are in form of gas, and these gas molecules are moving in a speed of gas. They are moving speedily because they don't need to pass through any medium. So the best answer here is diffusion. The second question: propane and carbon dioxide diffuses at the same rate, because now there's this point I want you to know. The rate of diffusion of gas is determined by their density, or inversely proportional to the density of the gases. For instance, now if you calculate the density of a gas by calculating the molar mass and dividing by 2, you get vapor density of a gas. Now, if the vapor density of a gas is higher, the rate of diffusion will be slower. So if the vapor density of a gas is lower, the rate of diffusion will be higher. That is, a very light gas can diffuse faster compared to a dense gas. So propane and carbon dioxide diffuses at the same rate because is it because they are both gases, or their molecules contain carbon? Option C, they have the same relative molecular mass, or both are denser than air. The best answer is option C, because they have the same. Let's quickly work out the formula of propane, which is CH3 CnH2n plus 2. That's C3H8. Carbon is 12 multiplied by 3 plus 1 multiplied by 8, which is hydrogen, is 1. So this is 36 plus 8, and that is 44 gram. Now if you look at carbon dioxide, carbon is 12 here, then 16 is oxygen multiplied by 2. We have 12 plus 32, which is also 44 gram. The best answer here is because they have the same relative molecular mass. To get the vapor density here, which is inversely proportional to the rate of diffusion, you divide the molecular mass by 2, you will get the vapor density. So the best answer is C. Which of the following gases will diffuse most rapidly? Now, any of the gas that will diffuse rapidly is the one that has the least molecular mass. Chlorine is at 5.5 multiplied by 2, which is 71 gram. Sulfur is 32 here, plus 16 times 2, which is also 32, and that is 64 gram. Carbon is 12 here, plus 1 times 4, and that is 16 gram. And carbon here multiplied by 2 plus 1 multiplied by 6, and that is 24 plus 6, which is 30 gram. So I think the gas with the least molecular mass here is methane, and so that will be the gas that will diffuse most rapidly, because the rate of diffusion is inversely proportional to their vapor density. Now this gas has 16 gram compared to others. Others has 64, 71, 30. So the rate of diffusion will be from methane to ethane to sulfur oxide and then chlorine. So methane will diffuse faster because it has the least molecular mass, which when divided by 2 give us the vapor density. And because the vapor density is lower, the rate of diffusion will be higher. So the best answer here is option C. Which of these phenomena can be listed as evidences for the particulate nature of matter? That's number 4 question now. JAM 2012. The first option here, okay, this phenomena, so sorry for that, we have the Brownian motion, we have osmosis, the next one we have diffusion, and the last one and the last one here is evaporation. Now they're asking that which of these phenomena serve as evidences for the particular nature of matter. Brownian motion, osmosis, yes. Brownian motion, yes, because they all support the fact that particles are always moving. Diffusion also supports that. Even evaporation supports the fact that particles are always moving. So the best answer is also option D, which is 1, 2, 3, and 4. Option 1 and 2, no. Option 2 and 3, no. Option 1, 2, 3, no, because all of them supports the kinetic theory of matter. The last question here is, what is Brownian motion? Brownian motion, from what we've done so far, is the irregular movement of solute particles continually in liquid or gaseous medium. State 2 inferences that can be drawn from Brownian motion experiment. The first one shows that matters are made up of tiny particles, and the second also shows the motion, that tiny particles of matters are always moving continually. This brings us to the end of the class. I must commend your effort for participating fully in this class. I want you to check more past questions, to search more questions under this topic, and also share, subscribe if you have not done that. Share these videos to many friends and watch out for our next class. Thank you.